Welcome to our channel. We are students of Vishwakarma Institute of Technology, Pune. In this video, we will be discussing about complete instruction execution with examples. We are group 12 from division G. These are my group members. My name is Atharva Jadhav, roll number 65. These are the contents. Introduction. In computer science, the execution of instruction is a fundamental to all functioning of a computer program. In this presentation, we will explore the execution of instructions, including examples of different instructions and their modes of addressing. Instruction execution overview. What is instruction execution? Instruction execution is the process by which a computer program performs the action specified by the instructions. Instruction execution is the process by which a computer central processing unit, which is CPU, performs the operation specified by a program instruction. In essence, it involves the CPU fetching an instruction from memory, decoding it to determine the operation to be performed, and then executing the operation by performing the necessary computations and storing the result in memory or a register. This process is repeated for each instruction in the program in order until the program has completed its task. Now, why is instruction execution important? Instruction execution is important because of what allows a computer program to perform useful tasks such as processing input and generating output. Instruction execution is crucial for functioning of a computer. It allows programs to be executed. Without instruction execution, a computer would not be able to perform a meaningful work. Additionally, efficient and accurate. Instruction execution is important for optimizing and performance of a computer system as it allows to run faster and with fewer errors. As a result, improving instruction execution is a key goal of computer architecture and design. What are the steps in instruction execution? There are several steps in instruction execution, including instruction fetching, decoding, operand fetching, execution, and completion. The steps in instruction execution typically include the following. Fetch. The CPU fetch the next instruction from memory. Decode. The CPU decodes the instruction to determine the operation to be performed and operands involved. Execute. The CPU performs the operation specified by the instruction using the operands. Memory access. If necessary, the CPU accesses memory to read or write data. Write back. CPU stores the result of operation in a register or memory. These steps are repeated for each instruction in the program, allowing the CPU to execute the program and complete the desired task. Now, some common instructions. Common instructions include arithmetic and logical operation, data movement, control transfer, and input-output operations. Instructions are basically building blocks of computer program and can perform a wide variety of operations. Some common types of instruction include arithmetic instruction. These instructions perform basic arithmetic operations like addition, subtraction, multiplication, and division. Logic instruction. These instructions perform logical operations like AND, OR, and NOT. Memory instruction. These instructions read or write data from or to the memory. Control instruction. These instructions control the flow of the program such as conditional parching and looping. Input-output instruction. These instructions perform input-output operations such as reading from or writing to a file. Transfer instruction. These instructions move data between the registers and or memory locations. These are few examples of many types of instructions that can be found in computer program.
I am Atharva Jadhav, roll number 66. Today we are going to see instruction fetching. So, what is instruction fetching? Instruction fetching is the process of obtaining the next instruction from memory. When a computer program is executed, the program counter, PC, holds the memory address of the next instruction to be executed. The PC is incremented to a point to the next instruction, and the instruction is fetched from memory at a specified address. The fetched instruction is then loaded into an instruction register, IR, which loads the current in instruction being executed. Coming to the next point, where are instructions stored? Instructions are typically stored in memory, which is a set of storage locations that can be accessed by computer's processor. What is an instruction register? So what is an instruction register? An instruction register is a hardware component that stores the current instruction being executed by the processor. So, in a basic computer architecture, the instruction fetching process involves following steps. So the first step is the PC is incremented to a point to the next instruction. The next step, the memory unit reads the instruction from the memory location pointed to by the PC. The third point, the instruction is then copied from the memory to the instruction register IR. Fourth point is the PC is updated to a point to through which it can point to the next instruction. And these are all the 4 steps of instruction fetching, and this is a complete instruction fetching process which is implemented.
My name is Chetan Jadhav and roll number is 67. So come to the point of instruction decoding. What is instruction decoding? Instruction decoding is the process of interpreting the instruction that has been fetched from memory. What are the common instructions? Common instruction includes add, subtract, load, store, compare and branch. What is the purpose of instruction decoding? The purpose of instruction decoding is to determine what action the processor needs to take in order to execute the instruction. Once the instruction has been fetched from memory and loaded into the instruction register, the computer must decode the instruction to determine what the operation it specifies and what it operates on. This process is known as instruction decoding. In a basic computer architecture, the instruction decoding involves the examining the bit of the instruction and interpreting them according to the computer's instruction set architecture. The decoding process may involve the breaking the instruction down into the different fields such as the opcode and the operands. The decoded instruction is then passed on the executing unit which performs the specified operation. This may involve the loading data from the memory or register, performing architecture or logical operations on the data, or transferring control to the another part of program. In more complex computer architecture, instruction decoding may be optimized using techniques like some microcodes, which use a small set of lower level instructions to implement each higher level instructions in the ISA. This allows the computer to execute the instruction more efficiently, since the microcodes can be tailored and or specify hardware implementation. This is all about instruction decoding.
My name is Daksh Jadhav, roll number 68. So we'll talk about operand fetching. First is, what are operands? Operands are the inputs to an instruction that are used to perform the specified operation. What is operand fetching? Operand fetching is the process of obtaining the operands for the current instruction that is being executed. Where are the operands stored? Operands are typically stored in memory or in registers, which are small storage locations within the processor. When a computer program is executed, the program counter, that is PC, holds the memory address of the next instruction to be executed. The PC is incremented to point to the next instruction, and the instruction is fetched from the memory at the specified address. The fetched instruction is then loaded into an instruction register, which is IR, which holds the current instruction being executed. In a basic computer architecture, the instruction fetching process involves the following steps. The first one is the PC is incremented to point to the next instruction. Second is the memory unit reads the instruction from the memory location pointed to by the PC. The third is the instruction is then copied from the memory to the instruction register. Fourth is the PC is updated to point to the next instruction. Next is the instruction execution example. So we'll take an example, add R3 and R1. The first step is PC out, MAR in, read, select for, add, Z in. Second one is the Z out, PC in, Y in, WMFC, that is wait for main function complete. Third one is the MDR out, IR in. Fourth is R3 out, MAR in, then read. Then next one is the R1 out, Y in, WMFC. Next is MDR out, select Y, add, Z in. And the last one is Z out, R1 in, end. And this instruction execution example is explained by this way, that the instruction add R3 R1 first adds the content of the register R1 to the value stored at the memory address pointed to by the register R3 and stores the result in R3. The steps to execute this instruction are first, fetch the instruction from memory. Second one is decode the instruction to determine the operands. Third one is calculate the effective memory address by adding the contents of R3 to 0. Fourth one is retrieve the value stored at the memory address calculated in step 3. Fifth one is add the value retrieved in step 4 to the contents of register R1. Sixth one is store the result of the addition in register R3. Seventh one is update the program counter to point to the next instruction in memory. So this is all about the instruction execution example.
I am Digvijay Jadhav, roll number 69. Now we'll take some information about addressing modes. What are the addressing modes? Addressing modes are the method by which operands are specified in an instruction. When a computer program executes an instruction that operates on a data in a memory, the processor needs to know the address of the data. The address mode specifies how the processor calculates this address. What are the different types of addressing modes? First one is immediate, second is a register, third one is direct, fourth one is indirect, and fifth is indexed. In an immediate addressing, the operand is specified as a constant value that is a part of instruction itself. For example, the instruction add 5 adds the value of 5 to the accumulator. In a register addressing, the operand is stored in the register. For example, instruction add R1 adds the value of stored in register R1 to the accumulator. In a direct addressing, the operand is stored at a memory location specified by a memory address. For example, instruction add 1234 adds the value stored at a memory location 1234 to the accumulator. In the indirect addressing, the memory address of the operand is stored in the register. For example, the instruction add @R1 adds the value stored at a memory location specified by the value stored in the register R. And in the indexed addressing, the memory address of the operand is calculated by adding a constant value for the content of a register to the base address. For example, the instruction add 10 in bracket R1 adds the value stored at a memory location 10 bytes after the address stored in the register R1 to the accumulator. Now, what do different addressing modes affect instruction execution? Different addressing modes can have a big impact on the instruction execution time and the amount of memory used by a program. Now, we will see the instruction completion and results. What happens when an instruction is completed? When an instruction is completed, the result of an instruction are stored in the memory or a register, and the processor is ready to execute the next instruction. How do instructions affect program flow? Instruction can affect the program flow by changing the value of program counter, which determines which instruction will be executed next. What are the possible results of an instruction? The possible results of an instruction includes changing the value of a register or a memory location, setting a flag to indicate the result of comparisons, or transferring the control to a different part of the program. These are the references or source of information. Thank you for watching the video. Also, if you find the video informative, please don't forget to like, share and subscribe. And you can ask the questions in the comment box below.